with wood here for a minute. And I know it may be understandable for some, but I see it all the time. So like almost everyone burns pretty wet wood. And it's in this climate in New England, that's hard not to do. You really have to be a year ahead. Like wood holds on to water very, very well. That's why trees can do the amazing things that they do. That's their job in large part, is to hold on to water. They hold on to water better than the best soil. I mean, it cannot rain for 3 months in the summer, which never happens here, but some places it does. And a log on the ground will be soaking wet inside. So those cells are amazing at holding water. So it takes a long time to dry wood as a result. You want to do it in the sunshine. You want to do it in as much airflow as you can. I once put up wood in like a shady part of a barn. In 3 years later, it really wasn't as dry as I like it to be to burn. So you got to get, better part of a year ahead. You need a full growing season. I like to have all my wood split and stacked by April 1st, May 1st at the latest for the next fall burning season. Late October is usually when we start to burn wood. So I see a lot of wood, around here. People get their wood delivered in, September, October for that winter. That's the time to get it delivered for the following winter if you want it dry. Every bit of moisture that's in the wood, you have to boil bring up to a boiling temperature, and then you start getting heat out of it. So if you remember back to, I think it was probably 8th grade physics, 9th grade, the kind of energy that's lost in that transition. So you want to get your wood basically as dry as possible. Sometimes I'll hear old timers just say, like, off the cuff, like, oh, you don't want too dry. Well, the only way your wood can be too dry is if your stove is too leaky. So you do want the wood as dry as possible. And that's important to keep in mind. That makes it easier to start the fire. You get more heat out of the wood than you would otherwise. It's a cleaner burn, which is a huge advantage. If you burn dry wood, you won't have to clean your wood, and you burn it well. You won't have to clean. I know some people are going to maybe take me to task on this, but you won't have to clean your stovepipe. You should still check your stovepipe every year for sure. Assume you may have to clean it, but basically I've done that now for more than 10 years. I have had to clean the stovepipes that I've used. I check it every year for safety. You got to check your stovepipe every year. And you should be prepared to clean it with usually a 6-inch stovepipe brush. But if you dry it well, you shouldn't have to. And if you burn it well. So that's important to keep in mind. So safety is a huge piece in drying your wood. You're also carrying a lot less weight in. I mean, thousands of pounds less a year carried in from outside. So that's really nice as well. But you got to get ahead of it. And sun, wind, those are your friends. So another big piece, I'm just going through the outline here, is that these are common mistakes I want to start with, is a poor draft. So a lot of people lately are starting to talk about like wood pollution in the home, which definitely can be an issue. I mean, any combustion source can be a major source of pollution, or source of any dust source too as well. And your draft configuration is the biggest contributor to that. So you want a pipe that's straight, no bends, if at all possible. Sometimes you'll have to put a bend in it. If you have a new build from scratch, a good design goal would be the wood stove goes in and there's no bends in the pipe. Like if you have to put bends in a new build, someone got something wrong. You really want to know where the wood burner's going, the wood stove, whatever it is, masonry oven, you name it. I'm a big fan, as you know, of wood stoves and wood cook stoves. But you don't want to have to put in bends. They're expensive. They're hard to clean, sometimes impossible, and you have to clean it in 2 spots. And they increase the danger in the system because of chimney fires. They tend to increase the likelihood of that. And they also worsen the draft, which decreases a lot of basically good things about your system, such as safety and interior pollution. So when you open the door, when your wood stove is going, you should be able to open the door and you shouldn't have any smoke coming out. So can you guys see that okay? If,
Yeah.
if you have smoke coming out here when the stove is hot, something's wrong with your draft. So that's really, really important. You're going to have smoke come off when you open it to start the fire. When the draft is cold, the stovepipe's cold and the whole system's cold, your draft may not be that good. So that's why a lot of people throw a big piece of birch bark or paper. Hopefully I'm learning more recently, not like take out boxes or anything with PFAFs in them or PFOAs. That's in a lot of stuff. All my ash goes to the garden. Those forever chemicals, don't want them in the garden for sure. So be very selective about what you put in your wood stove, because your wood stove is nutrient in a nutrient way connected with your garden and whatever you grow, ideally, because in this part of the world, we want those minerals and we want that raised pH to some extent. So it's really valuable, all the ashes. So we'll throw some combustibles in there, get the draft going, and then load it with wood before we want to minimize how much smoke we get into the space. Even if it's just a puff, that's like a lot of boxes of cigarettes you could think of. They probably don't have all the chemicals that most cigarettes have in them, but they have some for sure. So avoiding exterior wall stovepipes is a safety issue. It's a draft issue because it's super cold, and it's also an efficiency issue. You might as well have all the heat coming off the stovepipe in the conditioned part of your home. You, of course, have to use double wall stovepipe where you go through floors or roofs. That's often some of the most expensive part of the installation, the metal asbestos, they call it, but they're hopefully don't have asbestos in them anymore for the most part. But the double wall stainless stovepipe, you can't really see it, but there's one where it goes to the roof here. Those are super expensive, like absurdly expensive. You can spend at least $1,000, if not $2,000 on those double wall stovepipe if you're not careful, or even if you're following codes, depending on where you are. So you want to minimize bends in those too, because the bends in those are incredibly expensive. Having the whole stovepipe super cleanable is a really hard thing to configure. I've done, let's say, a handful of setups, and there's really only one I've done that's super, super easy to clean. And that's where you can climb up on top of the house with your stovepipe brush and feed it down in and have a box inside the house under a T where you kind of put a rag around it so none of the creosote dust can come out, and you clean it out, and it's super easy. Big plug for burning really dry wood, burning it really well. You don't have to clean it, but you do have to check it every year at the very least. So cleanable, super key. Some systems can be like, a 2-hour job to clean it and super messy if you're not really careful with how you install it, or at least an hour. And making a mess of creosote in your home is definitely not cool. You want to avoid that. And you want to have a sliding section of the flue that there's a special piece. You just got to ask about it if you do your own installation, and make sure if someone else is doing installation for you that they install it. A lot of people don't, which is a sliding section so you can get up in there to clean it. They're not really expensive at all for single wall, but you need that. So another big common error is sizing the stove wrong, especially too big. So a good way to think about this is thinking of like a diesel generator or a diesel truck, or really even any engine. Every mechanical system out there really has a sweet spot where it really wants to run most efficiently. So think about like a big truck. If you load it up, maybe you get a mile a gallon better than if it's not carrying anything. And so you want to size your stove or your engine, whatever it is, especially a generator, for the load you expect to have most of the time. So, and a stove really wants to run. It doesn't want to just kind of be in the bottom like 30%. It's like think about in a manual shift transmission being like where you kind of want to shift, but you can't quite shift, but you're bogging the engine down. That's how it is if you're running too big of a stove and it's super dirty. It's a dirty burn because you're going to be a smoldering burn. You're not going to be really cranking it a bit. You want to be like almost redlining like a diesel TDI, if you think about it that way. Like I used to drive a Volkswagen Jetta TDI. It's like you want to be in the high RPM, not in the red, but you want to be like pretty high. That's the best burn. So you want to burn at, let's say, 50 to 70% of capacity. So for a lot of people, that means sizing the stove down, not up. You definitely don't want it too small, of course, but almost better to have it a little too small, a little too big, I would say, from a clean burning perspective. Another piece is not optimizing the system. So if you've seen the video I sent you, you'll see how I check for air leakage. That's really key to do right at the beginning of when you get a stove. All stoves are pretty leaky for the most part, unless you buy potentially, I'm about to test some JA Roby stoves, which are really high efficiency, they look like, for a cook stove. And maybe they're going to be pretty leak proof. But most, even this Essie, which is a pretty high performance stove, has some leaks in it that I've had to tweak. You want all the air going in and out like where it's designed. So this is the air intake on this stove. You may not be able to see it very well, but you can hear it. And this is another air intake. That's a air wash for the glass. Essies are nice because they have this huge piece of glass. That's really, really handy and valuable. Glass is really key because you have to be able to see how your stove is burning to know like what to do. You need that feedback. So checking for leaks. A big, really good hack is supplying an air source. Now, I haven't done that yet on this stove. I've done it on one of the handful of configurations I've done, but you can take like dryer vent or different ducts and bring it in from the outside. For your average leaky house, this is probably the lowest hanging fruit you can do to decrease your energy use, besides for like air sealing, like super leaky parts of the house, is give your wood stove a supplied air source, meaning bring a 4-inch or 5-inch or 6-inch duct of air from the outside, drill a hole in the wall, bore a hole in the wall or jigsaw a hole in the wall somewhere or down in the basement. Get that air through the basement, through the floor, or through the outside wall to the stove. Some high performance stove comes with places to attach that. That's really great, but most stoves don't. You can bring it up just to in front of the stove, like at the base of the stove, put a vent on it so you can close it when you want to, when the stove's not running, and that feeds air straight to the fire, which means every cubic centimeter of air that's coming through that is a cubic centimeter of cold air not being drawn through your home, which is constantly cooling your home down. So you're immediately dropping. When you do that, all of a sudden the drafts in your home goes way down, like it's palpable. And homes that feel really drafty down low on a cold day start to feel like downright cozy when you start doing that. And that's one really interesting thing about a wood stove. It's putting the whole building under negative pressure because that fire is consuming a lot of air. So it's sucking air in through the outside. Well, it has to come in from the outside to the firebox. So if you supply that, all of a sudden the whole home is not under as negative of a pressure. Now, some of you may be thinking, if you have a very high performance home, if you have a new build, and it's super tight, you have blower door test and it's really off the charts, really good, then you probably don't want to do a supplied air source because you could actually suffer for lack of fresh air. So then you actually want to, you want some drafts, you want some fresh air coming through your house. That's kind of the place I've been, even though I don't live in like super high performance houses. I err on the side of like burning a little more wood and having more fresh air and better air quality. And that's one interesting reason why a wood stove can actually increase the quality of your air, because it's constantly sucking fresh air through your home into it versus damage your air quality. There are ways it can damage your air quality too. Don't get me wrong, and we'll talk about that. Another big one is mentioned in the notes, glass door. We've installed glass doors when they don't come with one, like Waterford Stanley doesn't come with a glass door. They should. And so we just cut the front part of the door out and put a glass piece in. We're lucky we have stove stores. I mean, even our local hardware store sells like stove parts and gasketing and stovepipe cleaners and even brushes sometimes. So it's great. We still have a lot of wood burning here. But in some parts of the world, it could be hard to get that stuff. You might have to order online. I can, luckily go to the local stovepipe place in Montpelier, Vermont, and just buy stove glass. I can also buy it online. So that's key. They're not very expensive. Here's a piece for resiliency for the people who are trying to really be like totally set up and prepared for, whatever eventualities or as many as possible. If your stove, your little kid running around or your dog or whatever, or just you being clumsy, breaks this piece of glass, you ain't running the wood stove. You don't have heat unless you have another source of heat, etc. So buy a piece of glass, put it in some bubble wrap or whatever, and put it away and label it really carefully and know where that is. Put a note in your phone or write it down, whatever, because the stove won't run without that. That's pretty much the easiest way to have the stove not running. Otherwise, it's pretty much, unbreakable all in all. Also remove the grate. So this stove came kind of outfitted for coal. Grates on the bottom of fireboxes are really for coal. They're not really for wood, according to some people anyway, and that makes sense. And so take the grate out, comes out down here. The stove's got some nice sugar maple in it right now. It's pretty hot. And so there used to be a grate in here. I pulled that out and I insulated the whole stove box. That's another really important tweak with Scamol. That's in your resource list. And you're going to get way more room, and you're going to keep your coals for like 3 times, 4 times, 5 times longer than if you have a grate on the bottom. Fire is not very efficient when it has air underneath it. So that's something to keep in mind too. You can do that with a Waterford Stanley. That increases its efficiency and its stove box size a lot, the firebox, because the firebox is really small in a Waterford Stanley. Okay, so some other mistakes we'll get through. We got 3 big ones more, and then we'll get into some other aspects to chat about. So locating in the home, big consideration, depends on a lot of aspects, such as the size of your home, where your kitchen is. But as I said in the video I sent you, you generally, if it's a cook stove, it's a kitchen appliance. You want it near your kitchen. So my kitchen here is right to my left. You don't want it really in the kitchen, because you want to do what I'm doing right now. You want to hang out by the stove. Anyone who has a wood stove in a really cold part of the world will tell you pretty much if they're in their house in the middle of winter, 90% of the time they're within like 5 feet of their wood stove. Pretty much. It's like the center, I'll just do my work here. I'll hang out here most of the time. So you want to put it where you want to hang out. Like one of the buildings we put a wood stove in, it was just on a tile floor, kind of in between the kitchen and the hangout room. And like we would just end up lying down on the tile floor. It really wasn't ideal, but the stove was there. So we're going to hang out there. So put it where you want to hang out, but next to the kitchen. Generally towards the center of the home if the home is more than about 5 to 800 square feet on the first floor or wherever the stove is. Having your wood stored near the door is really key, and being able to wheel it in is really key. I have one setup where I can wheel a garden weight cart in that's like a week's worth of wood and just dump it on a concrete slab. Very easy on the back. The situation I'm in right now, I carry it in by the armload, twice a day when it's really cold. That's fine for me right now. But, when I'm, I don't know, 70s, 80s, 90s, that's not going to be, very doable. So being able to wheel your wood in, if you're doing a new build or renovation, make sure your front door or the door from the stove that's between the stove and the outside is at least 36 inches, more like 42 inches would be good. 46 inches, 48 inches, you might as well make it wheelchair accessible, because you will be old someday and you will be hurt someday potentially. And you want to be able to wheel a garden weight cart in of wood and dump it next to your wood stove. That's like very good design setup. That's like saving you like 10 trips with wood in your arms. So another big piece is not integrating the stove. Like many of you probably heard me kind of rant about water heating a lot. Like we heat a 50-gallon tank super hot. Right now, we have the top of our hot water tank, it's 50 gallons, is like 150, and the bottom is about 110. If you know much about plumbing, that's a lot of hot showers and dishes and like clothes washing. So that's a lot of hot water. We get all the hot water we need, no problem. A lot of people I know have tried to heat hot water with wood stoves. Just, it doesn't work very well because they're not doing the, I'll get into the details of it, but they're just not having enough extraction of heat into the water system. And same with masonry ovens have tended to work even worse for that. So integrating hot water is a big piece. A tank that's 50 gallons or bigger seems to be best. We've done them with 40-gallon tanks. They don't work as well. The tank, for situating all this, the tank generally needs to be about twice as high as it is above the stove to the versus the horizontal. So if you're 5 feet horizontally away from the stove, you need to be 10 vertical feet above. Or if you're 2 feet over, you need to be 4 feet up. You can easily put that tank on the floor above your stove. And I would recommend it. You don't really want to have to look at it. It's, you know, it's a thing of beauty in some ways, but it's also kind of in your way. You want the area around the stove to be really good for drying, for people hanging out, for just drying all your clothes, boots, you name it, like tons of drying space above it and next to it. Really on all sides of it if possible. So you really don't want your tank there. You want the tank 1 floor above. No problem. We have tanks that are up to like 15 feet above the stove and it circulates great with a thermosiphon, no pump necessary. You want the tank accessible. That sometimes can be a challenge because you're going to have to fix it. You're eventually going to have to replace it. They don't last forever. Leak test it if you buy a used tank. I've never spent much on a tank. I mean, the nicest tank I have is in this setup, and it was actually, no, it's in a different setup. And it was like $350. It was from a solar hot water system that someone was getting rid of. Solar hot water is almost a dead industry, which is unfortunate because it's great. Solar domestic hot water. It's perfect to pair with wood stoves in this climate. Summer, you get 6 months of heating, no problem with 2 flat plate panels. And the swing seasons are when you're a little short of hot water because it's not that sunny, you're not burning much wood yet. So then a backup on-demand propane works well, maybe on-demand electric, and then your wood gets into kicking gear all winter. So that tank has worked really great. That's a 50-gallon Superstore, I think is the brand on that. Just a high efficiency, like very well insulated. Stiebel Eltron makes good ones, like, you know, a few inches of foam. We've used free tanks, and my neighbor was throwing out a hot water tank that was 40 gallons, and it was like a 5,000 watt electric tank that was costing him too much money. It didn't leak, so we used it. It works fine, but it doesn't hold the heat quite as well, and it's a little too small. You want to make sure to put safety valves in. You want to do this with like a good plumber, unless you get some nice plumbing chops, but put in, you know, the boiler high pressure drain valves, one behind the stove and one up by the tank in the high points. You got to know where to put those. I'm not going to give you like the safety advice on that for various reasons, but it's pretty easy to figure out where those go. And I put 2 in. You really only need 1 probably, but 2 is better than 1 for safety issues. They're not expensive. And when those go bad, they actually start leaking. They don't go bad in a way that makes things more dangerous. Flexible corrugated copper connections. That's a one we did in this one. My plumber, who's really savvy, made that call. I'll just show it to you. They help a lot. So you see that. Hopefully you can see it. It's kind of a mess back here, but that's a big piece of flexible copper, which allows the stove to move around a little. If you don't have some flexible copper, it's right here. You know, everything has to be just right, and it's pretty hard to connect all this plumbing. This is a union, which helps, you know, you want to be able to connect and disconnect the system if needed for maintenance. I haven't really had to do that, but at some point you will. So you can see another one over there. Flexible copper, corrugated copper. The Google will come up with that. They're not expensive, but they just give you a little bit of wiggle room, which is really key. Yeah, so those are some of the big key pieces for integrating the stove and installing it. And then as far as like keeping your fire and running your fire, there's a lot of mistakes made in that part of the operation, this is a system that takes skill. Like, it's not Alexa, turn up the heat. There's some skill involved here. And that's one of the reasons that a lot of people, aren't going to do this. But you can learn it. It's not that difficult. Keeping a fire, there's an art and science to it. This fire is made, so I can't show you that right now, but basically you don't want to smolder your fire ever. You want to get them pretty hot pretty often, not overfired. I wouldn't get the firebox. Well, I wouldn't get the flue temperatures more than like about 800 degrees or even 600 too often, but you want to give it the Italian tune-up like they talk about with diesel engines every now and then, and burn it hot, burn off the creosote, crank it a bit. Every system's going to work differently. I mean, some systems are prone to overheating and some aren't. This stove is not prone to overheating. I could leave this door open here, which is usually a big no-no, and this system's not going to overheat. Like, things aren't going to glow red. You don't want anything glowing red, by the way, like it's a forge, ever. You're damaging things then. But some systems, if you have like a 40-foot insulated pipe going straight up a huge house with tons of draft and tons of air coming in, I mean, you could create a jet engine in a bad way and like cause some major problems. So you don't want to do that. You want to build your fires, and you want to burn just really dry wood. That's the big piece, is burning wet wood will make things really dirty. Honestly, that's probably the biggest single common mistake. If you see people burning wood, drying wood in quotes, under like blue tarps, just know they're actually trying to make mushrooms, but they don't realize it. That's really what's going on there. You can't really dry wood under tarps. I mean, if you are super anal about it, maybe you could make it work, but generally those don't keep water off. They tend to blow around, water pools in them and then settles right through. Scrap roofing is what you want. So when you see scrap roofing being thrown out on the side of the road, you want those things. It's just like pallets, like you'll have a use for them. So make sure you have your wood either in a shed that's really airy or under scrap roofing, in its own stacks. Some parts to have on hand. Gasketing, that's really key. That's what's around the door of all the doors and all of the compartments. Have some extra of that on hand. It's not expensive, but you do need it, and they do kind of break over time. The fire brick inside and scamole, you want some backups of that around. That is a wear item to some extent. I mentioned the door glass, and McMaster Car is a great resource for that. If you don't know McMaster Car, get to know them. They're amazing. Just be careful on shipping prices, because they'll put it on your door like in 2 days, and you don't really need that, but it's expensive. So yeah, there's some other items listed. I'm not going to read them all off. Everyone will have the outline that Jeff has sent. There's a lot of decent stoves out there. There's some good ones. I haven't used them all. I've used Essie, Waterford, Stanley. I've seen the Pioneer Queens, and I'm about to use some J.A. Roby stoves. So I don't want to speak to anything I don't have direct experience with. But Obadiah's has a good list and resource for a lot of those stoves. Unfortunately, in this country, it's really hard to find most of these stoves, the cook stoves, especially I'm speaking of. I mean, there's some other great wood stove brands, Morzo, Vermont Castings. Morzo is a great brand. They make the nicest, smallest stove I've ever seen. The 2B is super efficient, keeps coals for like 16 hours, but it's a little stove. You can put it in a little office or a little shop, or a very small high efficiency house. So I don't want to like speak to all of the brands out there, but check out Obadiah's for a good list. You can go in as a group and get pretty good deep group discounts, I found, if you're ordering like, tens of thousands of dollars of stoves with like 5 to 10 people. A good wood cook stove new is going to be like $3 to $6 grand, maybe even a little more. So they're big investments if you buy them new. Waterford Stanley's I've always found used, sometimes for as little as $600 in good shape. They're not quite as efficient as the Essie, but they're really pretty good too in a lot of ways. Essie has some design problems with it that the Waterford Stanley does not. The oven, for instance, on the Essie just doesn't work too great. The Stanley, it cranks. And the oven in this Essie is, even though this is pitched as like a chef's stove from Britain, the oven sucks on this thing. It's not very big. You can't put a full-size turkey. We've gotten a turkey once, like beautiful turkeys from Green Mountain Girls Farm. Hey, Mary and Amari, and they wouldn't fit in this stove. So, or from Earthwise Farm, once we got a big turkey and wouldn't fit in here. So I don't know. You want a bigger oven than that. Wouldn't fit in the oven. This has a nice stove top. It's really hot, but it's also not flat like the Waterford Stanley, and that's key. The whole top of the stove should be flat, ideally. Yeah, so some of the other key considerations are in the video. I want to have as much time as possible for question and answer. We've gone about 35 minutes. We've covered a lot of info already. But let me just see in these other key considerations if any of it demands like a lot of discussion. I know I've mentioned some of this stuff already. Yeah, I think we've hit on most of this. I like to dry the wood I'm using next in the oven when I'm not baking, which is most of the time. We're not big bakers. And so I'll put like, this will be the piece that I start the fire with tomorrow. I'll have coals and I'll put this piece will be hyper dried and that'll go in first. You know, less time you spend, the better on the whole system. I probably spend 5 to 10 minutes like dealing with the stove a day. It's really not a huge deal. Dry wood, another plug for dry wood. So yeah, maybe, what do you think, Jeff? Should we jump into Q&A already? I saw there's a lot of activity in the chat. I couldn't read all the chat while I was talking, but, and let me try.
Yeah, there's a lot of good questions going on. Everybody's keeping me real busy here.
Great.
So yeah, we have some good questions for now, and then some good questions for like a more formal Q&A in a little bit.
Okay.
One easy one to just maybe get the conversation started is, where do you build the fire if you've removed the grate in the stove?
You just build it right on the bottom of the stove. So great question. Like this pan that's in there, the fire would be sitting, let's say here. That's pretty hot. So instead of sitting here, it's just sitting in the bottom of the stove. You do want to make sure you have some steel in there, because you never want the fire straight against the ultimate steel or cast iron sides of the stove, because you will wear those out. It's really interesting to realize, but fire wears things out. Like fire is like a jet of water, like a waterfall over time. Like it actually wears material out. So that's why you want the actual steel or cast iron on the stove to be protected by fire brick, which, you know, this is all fire brick on all sides, the back too, because that's like $20 of materials, and I can have like a stack of that for like the next 100 years on the farm. And so that's good stuff to have around. You want to wear that out and not the metal, like the stuff the stove is actually built out of. So on the bottom, it's not as important because the heat doesn't go down nearly as well. Honestly, you really don't have to have anything there as long as you keep some ash, like an inch of ash in the bottom of the stove. Ash is a super insulator. And if you have an inch, like some wood stoves will say, never clean out all the ash, like always keep some ash in the bottom. That's why. So that's a good question.
Cool. And when it comes to sizing the right stove for the space, is there a chart that, you know, people can look up? Does it depend on the stove that people are using? Or is there like a general recommendation for just say 1,000 square foot house? Like what size stove should people use?
Yeah, so that's a great question. Basically, you want to figure out your BTU load of your house. So every house has a certain amount of heat it needs. Don't pick the coldest day, but pick like, you know, a period that you'll have like weeks, let's say 3 to 5 weeks of the coldest weeks. How many BTUs is the house losing at 68 degrees or 70 degrees? That's what you need to be producing to keep the home at a constant temperature. So building engineers do that work. it's a little hard to figure out the exact heat load of your house. So one way to do that is just to go to similar buildings and try to extrapolate. But stoves are rated by their BTU output per hour. So this is like 50,000. I'm guessing it's about a 50,000 per hour BTU output stove. Yeah, and so this is a little building, but it's half glass, so it loses a lot of heat. I mean, if this was in our original studio, I'd be shirtless and sweating, right now. I mean, I already almost am, but like, because I'm super close to it, but the whole place would be like 80 degrees. Here, this is pretty drafty, so it doesn't keep up. So every space is different. When you look online or read books, it'll be like, oh, this stove's good for like a 1,500 square foot house or a 2,000 square foot house. That's all kind of BS. Like what 1,500 square foot house? There's many houses that are 1,500 square feet, which need twice as many BTUs as a well-built 3,000 square foot house. So it's all about your actual heat load. And yeah, without actually figuring that out in detail, which is a little tricky to do without like knowing. I mean, if you talk to a building engineer or maybe consult some building engineering books, or a good architect, you probably could come up with some estimates based on how much glass you have, the R value of your glass, how much insulation is in the wall, et cetera, and like come up with that. But the best thing I think to do would be to compare buildings and stoves through experience directly. I know that's
great.
probably a dissatisfying answer, but
No, I think that's great. And there are a couple more questions related to the common mistakes. Jerry had a question about venting the cold air into the house. So he can do that, but it's going to be about a 25-foot run. And he's thinking that there might be an issue with that long of a, having cold air run that far. Is there anything he could do to remedy that, or is that a concern?
Well, there's friction loss in pipes, but I don't think there should be a problem with that. You can always try to get a piece of, dryer venting is cheap, or you can maybe borrow some extra from someone and test it, like hook it up and just see, like on a cold day, how much air comes through. But I've never found, I once did it with 4-inch and it was fine. I mean, it flowed good. It was probably 20 feet long. I don't think that probably doesn't sound like that would be much of an issue, but if in doubt, size it up.
Okay.
Yeah.
Is there, obviously we want to burn the dry wood, or, have the ideally, but do you recommend using any of the soot removers or using any other, things you throw in there on a monthly, quarterly basis to clean
I
things up?
can't say I recommend that. I once bought a little bit of that at the hardware store because my son wanted it. It said it made colors, colorful flames. I probably shouldn't have got it, but I did. And we used it and it seemed to clean things off. And condense the creosote and like drop it down. Sometimes I'll tap the stovepipe with like a wooden spoon and just kind of like make a hot fire and just whap, 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 whap on the stovepipe, try to drop the creosote down. I don't know how well that works, but the last bunch of years and years, like at least 10 years, I haven't had to clean a stovepipe that I've used just burning dry wood hot. So that's my main recommendation. I don't know how those products work. And chances are, I don't know, every month that goes by, I'm realizing there's more and more crazy chemicals and so many things. And like, I might steer away from that. We put all our ash in the garden, as I said. And like, I realized that I have put like those, pick up, takeaway food containers that have the smooth sides. A lot of those have PFAS in them, the forever chemicals. I put those in my wood stove, like, unthinkingly. And then those go in my garden, and then that goes in my food. So be careful what you put in your wood stove.
Absolutely. In an older house or just an older build in general, do you have any tips on getting the heat from the stove out to the other rooms of an older house?
That's a tough one. I mean, that wants to inform how you design a home if you're designing from scratch in like a huge way. Radiant heat is just that. It's not convective heat. It does not move very well at all. You can use little computer fans in doorways. Those help. They're pretty low load. They're like a few watts, if that. And they work. those little bimetallic fans that go on top of the stove, I can hear it in my head now because I listened to one for years. They stop working pretty quickly. Like that was a waste of money, whatever I spent on it. I don't know. Maybe some of them last longer. I don't think they work too well, moving too much stove, too much air, stove heat. I'd say the computer fans, and then just vent, like overall air movement. So the configuration of doors that are open and how the interior is arranged. But ultimately, it's why you want a square or pretty squat rectangular home. If you're in a rambling home, you're not going to heat. There's going to be a back room or two that's like in the 40s, even if the house is pretty darn well insulated. And no matter what, if the wood stove is like a room or two away. And that's an unfortunate reality, but it's a reality of the situation. You can add a wood stove. I mean, you can put multiple wood stoves in a house. It's kind of a lot of work to keep like more than one fire going. Is like, it's all of a sudden makes you use a lot more wood. It's a whole nother thing to do. I think if you start having like a large family situation, like that could be worth it. But if you're like 4 people or less and aren't like making wood a big project, I would hesitate to say you want to ever consider more than one wood stove going all the time. You could take the chill off a room pretty quick with a little wood stove, but then you got to install it. You got to put sometimes hundreds of dollars, if not more, of stovepipe in. That's tricky. What a lot of families have done in traditional New England is just consolidate their use in the winter, and they just migrate into the core of the house in the winter. Or maybe they migrate out on a warm day. They use some of the other rooms a little bit or put on an extra layer and a hat. But you really kind of like come into the core in the winter, and then you inhabit the whole place for 6, 7 months, 8 months a year. And that's honestly really practical.
Are you ready to talk about some other types of heaters, like the rocket stoves or mass heaters?
I am. That's maybe the elephant in the room here. Besides
It
for
is.
the, where's my screen share? Oh yeah. I just made this today because my book revision needs this graphic. And so I'm going to, I just figured this was a good time to make it. So I'm just going to share my whole screen. Okay. So can you see my screen, Jeff?
Yeah.
Great. So here's that tank, by the way. This is right in Colleen's house right now. And so this, I'll talk about this if we have time, but that's the exact setup of so I have a screenshot here of, here it is, comparing heating options. So this is a good way of explaining some pros and cons of pellets versus wood boilers versus wood cook stoves, wood stoves, rocket mass heaters, masonry ovens. This isn't definitive. I mean, everything is contextual, but this is pretty good overview. So on the left here, we've got yields, like what are the outputs of the stove, like what are the heater? Why do we have the heater to begin with? We want to heat space. We want to heat water. We want to have a cooktop, etc. Does it require electricity is one of the questions that's shown here, because that's a negative. If it needs electricity, that's not an advantage. Some things do, but it's certainly not a good thing. How efficient is it? How suitable to a small home? The operating expense, lifespan. And then at the bottom, I put overall resiliency in a forested landscape and overall resiliency in a non-forested landscape. So this got a lot in it, but it's worth chewing on. We're not gonna get through the whole thing right now, but what I want to kind of distill down for folks is
screenshot.
Okay.
yeah. So here's the deal with pellet stoves and wood boilers. They look at all the red here. So red is negative. They need electricity. They're not running without electricity. So if you want resilience and not total dependence on the grid, which takes a lot of stuff to keep running, it's actually kind of a miracle it's on most of the time. at least here right now for the last 50 years, 60 years, you don't want a pellet stove or wood boiler. Plus, all of these two things are dependent on the global order working just fine. Global flow of parts, mostly from China, working just fine. If they do work fine, they're super convenient. I mean, they're way less work. The wood boiler isn't that much less work. And that should probably be medium because you still got to load cordwood in there. I should change. That shouldn't be high. That should be like medium to low. But like a pellet stove, if you have your pellets delivered, they just are augered in. Like it's pretty much like Alexa, turn up the heat type of situation. But so all of these don't require any electricity. And so they're in a whole different category of resilience, of course. Big difference between the wood stoves, these two, and the masonry oven and the rocket mass heaters, like mass-based heaters, are a couple things. And I don't want to blast these because they're amazing. These are very efficient heaters. They're more efficient than a wood stove. But efficiency isn't the only god here. Effectiveness is really more important than efficiency in a lot of ways. Efficiency is important, don't get me wrong. That's like how much heat do you get out per kilogram of wood you put in. They do better than a wood stove and wood cook stove for that, because they burn at very high temperatures. At 1,000 degrees is where most of the energy is, or 60% of the heat in wood is in the gases. You have to be at 1,000 degrees, start burning the volatile gases. So if you're below 1,000 degrees in the firebox, you're not even really getting more than, you're getting half of the heat that's in the wood. And wood stoves can burn at that too, but you got to be better about it. Masonry ovens, and rocket mass heaters, like it's easy to achieve. And then the heat is stored in the mass. The problem that I see with those two systems is they generally aren't very good at heating hot water that I've seen. Now, I think there's some case studies online that say maybe they do, but I've seen some very professional masonry ovens installed where they put water heating pipes in for clients. Like these are $30,000 systems, and they didn't work. They didn't heat hot water. And I can tell you, we heat hot water, like a lot of hot water, really well with a wood cook stove and a wood stove. And water heating is pretty important. I mean, you raise anyone out here, raise their hand if you want hot water. Like we're all going to raise our hands. Like hot water, beyond your space being warm, I would say, and dry. Like as long as it's not raining and snowing in here, and once it's warm, the next need I have is hot water. And your house can be colder if you have a hot shower every day. I don't know if you noticed that, but you're warm for hours after a nice long hot shower. Like it's a big part of like staying warm is hot water. And it's very therapeutic. The therapeutic value of it's super high. So that to me is nothing to sneeze at. Like hot waters, and a lot of people burn a lot of energy heating hot water. Like it's the second most highest energy use for a lot of people, unless they're very wasteful of electricity. Usually it's space heating, then hot water heating, and then electricity in terms of overall joules of energy used in the home. It's not small. So, and then another key use is cooking. I mean, cooking on the stove I have chicken soup on right now here that's been hot for hours, and just sipping on it, nursing it throughout the evening. Wood cook stoves can do that really well. Masonry ovens and rocket mass heaters generally are a little bit limited, or a lot limited, in cooktops, partly just by the nature of how they run. So their use pattern is you fire it once or twice a day, super hot, short burn. You don't want to, if you're firing it for hours a day, like you're going to burn through a ton of wood. You don't need to, and you're going to overheat your house. So masonry oven also, there's an imperative there, which is you need a bit of space to heat. I don't know how effective masonry oven heaters are in really small buildings that are pretty well insulated. I see them come into their own in like spaces with a lot of heat load. So like big leaky homes, or just big homes in general, start to think about masonry ovens when we work with clients as like a great option. But because they only are fired once or twice a day, they can't transfer that much heat into water that quickly, even if you use lots of pipes. It seems to be just a physical reality that it's hard to, like this stove is, let's say, hot on a cold winter day. Like today was in the 20s. It was pretty sunny. We had the stove out. Maybe we didn't load the stove for like 8 hours in the middle of the day, but then it's going to run let's say it'll run for 8 hours of the day. That's enough to make tons of hot water. If I only fire this up, say this is a masonry oven, I only am firing it for like less than an hour twice a day, I'm not going to have much hot water. I don't want to say it's impossible, because there's people working with like hybrid systems, which are worth you checking out if you're really serious about this. But until I see it and don't see just failures with my own eyes, I'm going to say what I've experienced, which is that masonry ovens and rocket mass heaters don't heat a whole lot of domestic hot water. I may get some hate mail about that. I'll read it. I'd like to be proven wrong. I've looked into the hybrid systems. I haven't built one yet, but I want to. That's the other thing about masonry ovens. What's a masonry oven cost? A lot of money, like 20 grand starting, 25, 30 grand, probably more nowadays. So, I mean, you could build it yourself, but you kind of need a lot of skills. Like, you can put a wood stove in and your stovepipe safely without a ton of skills. No specialized skills needed. The plumbing, a lot of plumbers know how to do that, and you could learn how to do that. To build the heater core of a masonry oven is a pretty specialized skill set. Like, I would consult with people to do that myself, and I have some masonry skills, and I still wouldn't be very confident, even if I studied it, that I would do it right. So that's like a big barrier entry. Also, beyond the high capital cost to masonry ovens. Rocket mass heaters could potentially be built for next to nothing with like cob for sure. Check out Oregon. They do a ton of them out there. But I think there's really good reason that you don't see masonry ovens or rocket mass heaters in like the cold parts of the United States and Canada. I don't want to short shrift masonry ovens. It's a super proven technology, like as proven as wood stoves, if not more, in Russia and Northern Europe. There's a huge history of masonry ovens. So definitely, but they also have a lot of skill there and have had it to build those. So there's a challenge there, but worthy of investigation. Those are the big pieces. There's a lot of other pieces in here. You guys will have this recording, so you'll have this before anyone gets my new book. You'll have this graphic. Yeah, but safe to say, if you want resilience, this whole pellet wood stove boiler thing is forget about it. And if you really, the question is between a wood stove, wood cook stove, and maybe a masonry oven rocket mass heater. But still, there's the barrier to entries there I mentioned for especially the masonry oven. Don't get me wrong, masonry ovens are beautiful. They're immense, incredible features in a home, especially in a new build. They can be much more practical than in a retrofit because they're so big. Mass, to work well in a home, thermal mass, you're talking not hundreds of pounds. You're talking starting in the thousands of pounds. So when people, like I used to put bricks or rocks around my stove, like early on, that's not going to do anything. Like if you start building partition walls in your house out of stone, then you start to benefit the home. But to back up for a minute, as far as like overall architectural engineering of a home in a cold climate, the two important pieces are not just insulating well, they're thermal mass and insulation. So insulation is really important. Everyone knows about that, but thermal mass is equally as important in a lot of ways. So having a lot of weight in the home that you get up to temperature to create a thermal flywheel is really key. Timber frames help with that. Stone hearths, but you're talking like thousands of pounds of heavy materials. Drywall is a little bit, but if you can know you're really never going to want to move like this partition wall, build it out of stone. I mean, it takes up some room then. It's not going to be a stud wall this wide. It's going to be, at least like this wide, but that will start working well. Also plaster walls and roof ceilings can, you can add 10,000 pounds inside your house pretty quickly with plaster, just by ½ inch of sand on the wall, lime plaster. So that's worth mentioning. Yeah.
What about stoves with catalytic converters? Some of the newer stoves have that. Would you avoid those, or is there a way to retrofit one if the stove does have that?
I would avoid catalytic converters. I once had a Hearthstone Harvest stove, the first one of the first stoves I bought after college, and it had a catalyst. And catalysts, for as far as I know, have only become nightmares. and they go bad, they're expensive. And nowadays they figured out how to run wood stoves more efficiently than anything with reburn systems that last a long time. So I would avoid catalysts for sure. A big piece. So my friend and colleague Eric sent me this. I sent him a spreadsheet I was making on energy return on energy invested, which is right here, as far as, because this is where it boils down to like societal level of energy use. And he's like, oh yeah, he's like, he, of course, being a geek like me, had already made a spreadsheet on his wood use. And he just costed out just how much it would cost. And this is something that's so basic we haven't even talked about yet, because I'm kind of geeking out on it. But like burning wood is way cheaper than burning oil or kerosene, which is also oil. But he figured, you know, it's at least like better than twice as cheap, like half the cost. I didn't figure out the cost benefit here. I figured out the energy return on energy invested. And so for a lot of people who are starting to think about, you know, we're being sold all these like renewable solutions, none of which are totally renewable, but they seem really renewable compared to diesel and gasoline. And they kind of are, but it's not so simple. I figured with embodied energy, I'm getting about 37 times the heat out from the land in the form of wood. So for every gallon of gas I burn in my chainsaw or my tractor diesel, I'm getting 37 gallons of petrol worth of wood energy. That's a pretty good conversion. And that includes the energy it took to build the tractor, which is a lot of energy. Actually, it's nothing to sneeze at. It's right here, 60 million BTUs. And I figure I use 35% of the tractors used for the firewood operation on my farm. The rest of it's used for, you know, haymaking and just moving stuff around, building stuff. But that's pretty good. We don't have to do a deep dive down that right now. We don't have time, but it's a pretty good turnaround. And I think it's worth mentioning, it's certainly high level essential to understand that wood is the only energy source that we can heat our homes with, which is regenerative. I know it sounds like oversimplistic, but if you think about it, trees, when they're growing, are making oxygen, they're making habitat, they're making soil and this whole soil food web. They're cooling the earth, they're breaking up the percussion, the raindrops, they're preventing erosion, they're doing all of these regenerative forces. If you look at a solar panel, forget all the harm that goes into making the solar panel, which is significant, and the energy that goes into making a solar panel. When that solar panel is running, it's nothing like the tree. It's not doing anything regenerative. It might be totally clean and it's giving you kilowatts energy, but there's nothing regenerative anywhere in the system of a solar or wind power system. It never gets to be regenerative because there's no life force being harnessed and being utilized. So it may be a lot less bad, maybe in certain situations, probably for sure, but it never goes it never goes past the neutral equilibrium, you know, the neutral axis into being regenerative. The way I manage my woodland here is pretty easy to make the case that it's actually regenerative. When I drop a tree down, sun's coming in and we're creating like mid-succession habitats, which absorb more carbon than later succession habitats, forested ecosystems. And you're actually like almost instigating and kind of like stimulating the growth process in the system. So disturbance can be a good thing within life systems. It can be a bad thing, but if you do light, very strategic disturbance, like grazing, grazers know disturbance can be regenerative if it's done well. Certainly in silviculture, it can be regenerative. There's no level of mining disturbance that is good. Like there's no like I'll mine a little bit of lithium and it'll be a little bit regenerative, like or cobalt or copper and all the things that go into the non-biological energy. So I just want to, it's key for us to understand, you know, that bigger energetics and kind of biologics at work here. So that's worth mentioning.
At this point, I love if people want to raise their hand, if you still have a question, and you can come on and ask Ben directly. Got about a half hour left, if that's cool with you, Ben.
Yeah.
All right. Hey, Tim, can you unmute yourself?
Yep. Hey, do you hear me?
Yep.
Awesome. Hey, Ben.
Hey.
I was wondering, with the hot water heating, have you seen any systems where they were tapping into existing hydronic heating systems in a house? Like we have radiators and a oil boiler that we're wanting to phase out, and wondering if there's any practicality to, powering the radiator system with hot water off a wood cook stove.
Yeah, it's something I thought a lot about. It's interesting, but I don't think there's quite enough hot water being made to do that. Like I would be putting a lot of my water into the radiant system, into the slab, for instance, or a radiator, and I wouldn't have as much for showering and dishes and what I really, really need it for. And it's already heating the space. So it's doable, but you just are going to up your BTU load. And every time you transfer energy, you're losing efficiency. So it already is going to space. When you move it into water and you start moving around, you're losing some of that efficiency. So I haven't seen it done, but it's certainly doable. I mean, if you have a wood boiler, like a huge output, a larger output wood furnace, you could do it. And it's done, all the time with wood boilers.
Right.
But so, and hey, Tim, I didn't realize it was Tim Tim I had said hello to before from our course.
Yeah.
Good to see you, man.
Yeah, you too.
Yeah. Yeah. And there's also some safety things to consider. Like you do have to keep the hydronic side and the domestic side separated, because if you never want to be able to drink the water from that's like going through your radiant system.
Right.
Like you get Legionnaire's disease, and you just get a lot of phthalates and plastics. You want to be in the habit in general anyway of never using the hot side of your sink if you're going to drink it or eat it. Like just use the cold side. If you're going to boil water for cooking, don't use the hot side, because that's coming from your tank. It's not as cool of a delivery system as edible.
Awesome. Thank you.
Yeah.
Jim Parker, do you want to hop on now?
Yeah, is that microphone working?
Yep.
Oh, cool. Ben, I was wondering if you had advice for shopping for used wood stoves, things that commonly wear out, or do you have like a checklist that you're looking for when you're looking for used?
That's a great question. And hey, Jim, good to see you.
What are you drinking?
Oh, this is this fall cider. It's only like 2 months old, and it's already pretty good, I must say.
Cool.
Very good. It's aged quickly. So yeah, I mean, I found Craigslist mostly, or Facebook Marketplace, I guess, is kind of replacing Craigslist. The thing you'd want to look at are for any cracks or anything where it's worn out. What I was saying before about how the heat will wear things out. Look through the whole heat path from the bottom all the way through it to the top, through where it goes into the flue. Just chase it and look for warpage and cracks. It's pretty easy to evaluate a stove. Like it's nothing like buying a truck, a used truck or something. Just look for cracks and warps.
Nice. Cool.
Is really it. Make sure everything works. I mean, I wouldn't worry about like little leakages, because those are fixable. They're a pretty safe thing to buy used.
Nice.
Yeah. I mean, make sure the door is like true. If things look for warp, anything being out of true, and cracks, obviously. But that's really it. I mean, hardcore rust that is deep, but you could fix some rust quite easily. It could look pretty bad and be a good stove, honestly. You just got to make sure the pitting, if rust is there, isn't too deep.
Right on. Nice, thanks.
Yeah.
All right, we got Keith and Erica next here. Hey Ben, how's it going, man?
Hey, how you guys doing? So many.
We're good. This is great
faces.
info. Thank you. 2 quick questions. So on your the hot water system diagram,
you have a cold water feed tank. Should that be 40 gallons or match the hot water tank or?
Great question. So can you guys see my screen still?
No, you have to
No.
share.
Oh, I'll share that. I'll share that, that drawing. Okay. So everyone see that now? That's so this is the drawing for my book. This is to feed the system if like when your well pump breaks, not if you have a spring up on the hill, you don't really need this, but most of us don't. So you can have your own like water tower essentially in your house. The bigger that is, the better, Keith.
Okay.
Yeah. I mean, that can't be too big, except it can be too big for your house to hold it like physically,
Right.
but like it can't be too big as long as structurally or your house can hold it or you have the room for it.
Okay. All right, cool.
Yeah. The more of that, every gallon of that is just, gallon of water you have to use until you're out.
Gotcha. And then the second part was you mentioned accessory heating like propane on-demand system. Where does that fit in on the diagram? Like where would you have a on-demand hot water system?
Yeah, great question. That just comes off. We should add that to this drawing. That just comes right here.
Okay.
Anywhere after the wood tank on this line is another T that comes from an on-demand, like that. There's well, basically this hot goes through an on-demand in my setup. And so the on-demand theoretically can check the temp coming in. If it's not hot enough, it just adds more heat. So you'll never be without hot water if you have like propane or electricity to supplement it. So it can be very convenient. In practice, the on-demand heaters don't really do that well. They don't expect, the engineers that make them don't expect that water's coming into them at like 110 or 100 or 90, which is like warm, but it's not really warm enough for a good shower. Like you need like 120 or so, 115 to have a nice hot shower. So sometimes in the swing seasons, our tank is like 90, 80, 90, 95, and we'll have like a cool shower because the on-demand doesn't want to come off. So what we've learned is we actually have to just turn a ball valve to send just straight well water through the on-demand, not from the hot water tank, from the well or the cold feed or your spring, whatever it is, and have the on-demand on straight off of the well. So you're not using any of the wood heat essentially. So it's kind of it's not so optimized, like, because then you just have this 90-gallon tank just sitting there because you're having like intermittent fires in November. But the on-demand tank, the on-demand heaters just aren't that smart. They don't want to add just like 15 degrees. They kind of want to go from like cold, like 45, 50 degrees to 120.
Right.
And that's kind of a bummer. Like maybe you could find an on-demand. We have a Takagi, and maybe you could find one and like look. It'd be very hard to get the answer to that question. You'd have to talk to almost like their engineers, which you wouldn't be able to, and say like, I want to find the one that will just add 15 degrees. Unfortunately, I don't. It might be impossible. But like what I said, we just kind of turn off. We just turn off the wood then, the with a valve.
Cool. Thank you.
Yeah.
You good for a couple more, Ben?
Oh yeah, I'm good for a
Awesome.
lot more.
Great. All right, Ross, you want to hop on?
Yeah, sure. Hey, Ben, this is great stuff. Thanks for doing this.
Hey man, good to see you again.
Good to see you. So I got a quick question about the logistics of getting the pipe running through the wood stove. So like, is that model of wood stove manufactured in a way that it's built to receive those pipes, or do you have to like bore your own hole to run those through?
Yeah, so that all depends on the stove. The Waterford Stanleys, like this drawing is based on a Waterford Stanley, but it could be based on anything. And it's just there's a water jacket right here, right? So that's in and that's out. There's a water jacket this big. It's like a little suitcase, it's like the size of like a book, like a big book. And so some stoves will come with that, and some you can like, they have holes already in, you can buy it and just put it in. The SE has that, But what we did in that video, I show you that we sent everyone how we added pipes through the top to give us more surface area for heat. So there's a water jacket, plus there's 2 stainless pipes running through the top, and we just bored holes in it. So like we just made I just jigsawed this hole. This is just the baffle, but then in the steel, which is like 3/16 steel, I just bored a hole in that for 2 pipes. So the thing is with steel stoves, you got to go slow and be careful, but you can just drill 1-inch holes.
How do you even drill and steel that thick? Like, do you get that on its side in a drill press or?
No, you hand drill it. You start small and you work up with bit sizes.
Okay.
And you use oil and you go really slow and you hold the drill really tightly and you just go from, start at 1/8 inch and go up in increments like 1/8 inch. And they make some bits that are literally for just upsizing holes for that job, but you can do it without that. You just got to go slow and it sucks, but it's not too bad.
Okay, cool. Thanks.
Yeah. Yeah.
All right.
I would
Colin?
definitely recommend like covering the water jacket, which is what we did in this, and we didn't do in the Watersford Stanleys. So the water jacket in this stove is right there. And that's why you see this panel, because it used to be exposed to the fire. And I just covered it with some scamol because otherwise it gets real creosoted and I have to scrape it and it's kind of a pain to get at it. And I didn't need that much heat actually. With the 2 pipes that we put in the top, I didn't need that much hot water. Like I didn't want that much energy put into the water.
Gotcha.
I know this part may sound a little overwhelming, but honestly, it's pretty simple. But I mean, using a good plumber who was willing to do this, many are not. If you're not much of a plumber or metal worker, would be recommended. Like licensed plumbers often like won't do this because this is not a UL listed system. So all like appliances in a home, according to certain state codes, not in all states, but in some states and some countries have to be UL listed, underwriters laboratories, like tested, all part of the whole system of regulation. And so this is not obviously UL listed, but it's interesting in some places that have more regulations for most things like Britain, they come off the shelf and like, this is UL listed. Like in Britain, this is UL listed, but in the US it's not. So you could have trouble finding, plumbers who will want to do it.
Colin, are you ready to hop on now?
Who, me?
Sorry, Kolin.
HOLL? No, Colin? No,
Yeah.
I'm Michael. Oops.
Colin, if you're here, you can unmute yourself.
Maybe we'll try the next one and we'll get back to it.
Yeah. Who's
I don't know if
next?
they're here anymore. Or
Antion? Sorry if I'm saying that wrong.
Hey Ben,
hey, how's it going?
good and you?
How you doing, man? Good to see you, Antoine.
Same man. Thanks for doing all this.
Yeah.
Yeah, so my question is the hot water tank. Because as you mentioned, those have like pretty bad materials in them. I mean like toxic ones, and they also have like a lifespan going for like 20-25 years. Do you know
Yeah.
other system that could be used to add longevity to the system?
Well, you could potentially, a friend of mine just had like a copper still tank, like a copper tank. And you could like just get a copper stainless like milk tank, like a bulk milk tank, and put it on its side and maybe put, weld fittings into it and then just insulate it, like build a wooden box around it and fill it with cellulose or wool.
Yeah.
that works. I mean, people do that with hot water tanks, actually, when they make their own. They literally will just build a box around it and dump like 10 bales of cellulose in it, or a bunch of wool, or what feathers, or whatever they have. Seed hulls, sawdust works great. That would be maybe like just a longer term system.
Because is there like any pathway the water gotta take, like inside of the heat tank, the hot water tank, sorry?
Yeah, so the hot water is coming up here, right? So this is hot water, and it's traveling at about this speed.
Uh-huh.
I've tested this, I can figure out how fast it's moving a few different ways. And so I find it moves about this quickly. And then it goes in here, and in some tanks, they're all different tanks. In some tanks, it's in a coil. So it's actually in a tube, and that tube is just coiled around and around, back and forth. And then it comes out here, and it's getting heavier as it gets colder, because colder materials are heavier than warmer materials. The molecules are closer together. So it's less buoyant, it drops, and then it comes down here and it sinks. And so this whole thermosiphon is going on just like this with no pump. And that's just what's happening while you're running the stove. It's just, you're essentially stoking this flywheel with the heat by applying heat to it. In some tanks, this is open. So this goes in here and the whole thing's open. And then it's just settling down and then dropping out. Either way, the important thing is a lot of new tanks are designed really well where the stratification is very high. You want as much stratification as possible. When cold water comes in, so this is cold supply right here. So whenever you open the hot water in a shower or a sink or whatever, the same amount of water that comes out of your sink has to come in here to replace. I mean, this is just how all hot water tanks work. And the hot water, the cold water, cold supply has to come in. That has a pipe that goes all the way to the bottom. And new tanks are designed so that as that water comes in, it disturbs this water, the warm water, as little as possible. So you get as much stratification as possible. Because you could have, you're having 45-degree groundwater temp water come in here, and you could have 145-degree better than shower water, like up here, just chilling, not being disturbed by that. So without getting into all the dynamics of that tanks and stuff, which I'm not even an expert at all, that's basically what's going on to consider.
So all that would have to be replicated in like a handmade like tank, right?
Yeah, but I don't know how well you'd have to replicate it. I think the really important thing is where the cold supply comes in. It comes in from the top and it goes down, and it's like somehow you design it so that it introduces with as little turbulence as possible. Like the worst thing you could do would be to put that cold in like right here on the side at the top, right? Because then you're showering off of the cold water you're introducing, right? Like, so that would be like the worst thing. So if you understand what the worst thing is, maybe that will help you think about, all right, what would be the least mixing way to do it?
Great. Thanks,
But I
man.
bet you could, I bet there's some info about that online, like how these tanks are designed. But what you're looking at here, everyone, this is essentially a tank the way it's set up anywhere off of any furnace, whether it's a cook stove or a propane boiler or whatever. Like the tank doesn't know the difference. The tank this is how all tanks are set up, all hot water tanks. So just to kind of like, I know it may seem really complex at first, but it's actually like every house pretty much is like set up this way already. It's just the boiler isn't a wood cook stove. It's, a propane boiler or a oil boiler or whatever.
Is the tank pressurized?
Yeah. So all of this is under pressure, like typical house pressure, 45, 50 PSI.
Okay,
You
thanks.
could have an unpressurized system. And that's what this is here. It's called an open system. So this, if I'm using, normally this whole thing's under pressure. And if and when the grid or the power or the well pump fails, I flick a ball valve off the well. I flick one right here. See, it says high quality ball valve. I flip that. It's in the closed position in this drawing. And then I open this one, or I open this. There should be another ball valve actually right here. We're missing that. So I open a ball valve here. I just flick two ball valves, and all of a sudden I just have gravity feed hot water from this tank pressurizing the system instead of the well. And it's lower pressure. Some of you may be thinking, well, how high can that be? That's only like 10, 5, 10, 8, 15 feet above the tank. Yes, because it's in a house. So all of a sudden I'm working with like 10 PSI or 5 PSI, but you can actually shower with like 5 PSI. It's not a shower you would leave a nice Airbnb review about. Don't get me wrong. It's like, but it's not a dribble. Like, it's a shower. And you're way better having a hot shower when the grid's been out for a week or a month or a year than having no hot shower. It's not like, you know, the amazing rain shower thing from like the Costa Rican resort or whatever, but it's a shower. And it's hot.
Thanks a lot, Ben.
Yeah, good to see you, man.
See you around.
Awesome.
All right, Clayton's here. I know Clayton had some questions. They sent in via email too.
Yeah. Hey, Clayton.
Hey, Ben, my question just got answered. It was going to be about a pressurized system from Gravity Feed Springs. So
Cool.
that just got answered. But how about that question about the cylinder stove that I emailed in?
Right. Yeah. I mean, that looked cool. You know, Clayton sent a photo in of something from Obadiah's, which was just like a wood boiler, as far as I could tell, to heat hot water. Yeah, like you can totally do that. I don't know that specific system, but there's so many ways to heat hot water with wood for sure. I don't know that exact you know, that appliance that you sent me, but was there, did you have a question about that in particular?
Yeah, I was just curious if you're familiar with those sort of like cylinder designs and how they compared to like the Waterford Stanleys and stuff like that. But
Yeah.
but
I'm not. I think that probably, since it's marketed as a boiler, that probably has really high heat output, BTU output for water. Like maybe it's like 50 or 80 or 100,000 BTU output into water, which is cool, but you probably don't, unless you're running like lots of bathrooms and lots of people, you probably will burn a lot of wood to get that much hot water.
Right. Gotcha.
That
Okay.
looked to me like a high output, like water situation, like not like a private, small, efficient house, you know?
Yep, that makes sense.
Yeah.
Cool. Thanks,
That's
Ben.
where, yeah, that's where like this system is like, I use 2 or 3 cords of wood max, and we get all the basics with that. It's not like an endless amount of heat on any one thing. Like a lot of modern homes, like the more you want, the more it'll make, which is convenient, I guess, but like you also pay for that with a lot of consumption. So, you know, this is the diesel, the Jetta TDI wagon version of things. Not the, you know, not the F550 with nothing in the back, but I could carry something in case I need to type of situation.
So Ben, we're getting close to time here. I think we
Yeah.
should take one more-ish question. But I would love to ask people if we were to do a follow-up training just to cover some more stuff that we weren't able to get to tonight. Would you be interested? You can just throw in the chat, I'm interested. Ben and I talked about maybe doing a series of these. So there's just so many great questions, and we're getting to time now.
Yeah, I mean, you know, we can spend a few hours on this topic, obviously, more and more. I mean, without covering it all. This is how to heat your house, how to heat your hot water with as little resources as possible from wood, a local resource for many of us. So it's obviously incredibly important. You know, it's worthy of a few hour exploration, to put it mildly, but we've done what we can with an hour and a half and that other extra video. But yeah, we're really excited about people's input and questions.
Cool. Well, let's finish with one more. Carol got their hand raised up. If you want to come on, Carol.
Hey, Ben.
Hey, how's it going? Carol from
Oregon,
right? Hey, good to
Yeah.
see you.
Good to see you. Do you have any knowledge about these stoves that have a couple of propane burners on them? They're wood stoves, wood ovens, but they have propane burners so that, for example, in the shoulder seasons or the summer, you can still cook on it Have you any experience with any of
I
those?
have never seen those. That's interesting. Yeah.
Okay. All right. I was gonna.
We just, we just go to our propane stove and, have a propane range. But that's interesting. That's like integrated in with the wood. That seems a little scary to have the wood stove have propane in it.
Well, I mean,
Like, I
there's
don't think
quite
I'd
a
want
few of them that
propane
do.
piped anywhere near my wood stove.
Okay. All right.
But
Fair enough.
yeah, that's
I'm-
worth considering. I mean, propane can get a little sketchy.
I don't know how they do it. I can't think of the name of it. I wish I had it up on my screen
Yeah.
saver so I could show you. The other thing is just for reference. This is an Obadiah thing from Obadiah's. They talk about range boilers versus domestic hot water tanks, and they were saying that actually, and obviously you've proven this wrong because you've done this a lot, but they do say that using an insulated domestic hot water tank is not such a great idea because they're not designed for the high water temperatures that solid fueled appliances produce. They're thinner and can rupture, and that they're glass lined, and that they're not cast iron but sheet metal, and they, when they expand and contract, they can rupture. And they do ones that actually have they call it a range boiler, and it's got it's not actually insulated. It's got like a concrete outside.
Right.
But anyway, that's available for people who want to check on it. I don't know anything about it, but you're obviously.
Yeah, early on, I read that, I think I had read some recommendations against, doing this because of that reason. And also, people talk about Legionnaire's disease as having tanks that maybe don't get hot enough, which is the opposite problem you're mentioning. And I see the way oil boilers fire, from a boiler to a hot water tank and propane, because we have buildings that we manage that have those, and they get just as hot as the wood stove.
Okay.
Yeah. I mean, you could get the water hotter. I have, in one of my systems, boiled the water twice. In the Waterford Stanley system, I boiled the water 2 times, once intentionally to see how it would work and once unintentionally. And the water blows off the back with the pressure relief valve into a bucket. But if you're managing it well, you're not going to have the water ever more than about 160. Once our water tank starts getting about 150, 160, if my family's away for a few days and I'm cranking the stove and I'm not really using much hot water because there's only one person here, I'll sometimes have to take an hour-long shower bath.
That's when you need.
Okay,
that's when you need a
good
hot
problem to
tub.
have,
That's when you need a hot tub that you can just
I
pump it
know.
all into.
It's good for my back. The therapeutic value is very, very high.
The name of that stove I was thinking of is called Elmira Fireview 1842G. It's a wood cook stove with a side gas range to it.
Okay. Yeah, I've heard of that stove, but I haven't used it.
Yeah, it's a pretty stove. I think it might be oversized for what we need, but it's got a small firebox. But anyway, I was just curious.
I mean, you're near Portland, right?
Yeah.
You don't need much heat.
Well, we bought land up by Silver Falls State Park, and that's at 1,600 feet. So
but
it's a bit colder.
Pretty mild all in all, right?
That's correct. Yeah, it's not Vermont.
Yeah. Yeah, it's, when the temperatures get teens and below, it's a whole different world than in the 20s, 30s. It's almost that's cool weather compared to once it's single digits below 0, it's all of a sudden just a whole different world.
That brings up, I mean, I don't want to monopolize, but one more question about that. I had never, I was so fascinated with rocket stoves and masonry heaters, but what you talked about, I never thought about before, about how you're only burning those once or twice a day, probably in our climate once a day. Right. And so they're not good for water heat. And I was trying to think we would have a very large shoulder season. Right now it's 45 degrees average in the winter. So I'm trying to sort out I don't know, is that going to be viable for us? Because maybe it'll be too hot. I don't know.
I can't imagine how a rocket mass would work in such a mild climate. I mean, I don't know. I could be wrong. It would take the chill off all the time because the whole mass would be warm. But you'd probably end up firing it like just once every other day, maybe, or something.
Right.
But
No
yeah, I mean,
cooking and
our
no hot water.
average temperature across the whole year is 45 degrees.
God.
And that's what our groundwater temperature is too.
Well, thanks a lot.
Yeah, thanks. It's good to see you.
All right.
I'm happy to do, a couple more if anyone wants to hang out. My son hasn't raided the house yet. They're next door to give me a little space, but once he comes in, it might change things.
Cool. Well, we got a lot of people that said they were super interested in doing another session, so that's great. So we can
Great.
say to be continued at any point. But there are a couple more hands up. And Ben, yeah, if you want to hang on, that's an option too.
Yeah. I mean, go a little longer if there's some pressing questions. For sure. So nice to see everyone. Hey, Colleen, and sees all these familiar faces here.
All right. I think Lindsay and Eric already had a chance to ask a question. Forgive me.
No,
Is
we
that-
didn't.
Oh, you didn't? Okay, good. You're up next then.
We live in southern Missouri, and so we don't have a lot of cold weather in the winter. It can get cold, but it doesn't stay cold long. So we're kind of in that shoulder season for quite a while. So maybe you can't answer this, but kind of what do you recommend for people that kind of hang out in that shoulder season for heating water with wood?
Yeah, solar hot water.
Okay.
Yeah, I mean, the milder you get, the more I move towards like solar, flat plate, maybe evaporated too, but solar hot water systems are great. 6 months a year, we have a 110-gallon tank in one of the buildings we have set up these systems in. That's just piping hot, like 150, 160 degrees, 110-gallon tank. You could put that to a hot tub, you could fill a hot tub basically. With 2 solar flat plate Stiebel-Eltron panels.
Okay.
So in a lot of the more mild, anyone who's calling in here from zone 5, zone 6, especially 7 more, just put solar hot water panels on your house or right next to your house, as close as you can to your utility room. And I mean, you could start heating your house with those too, and put a big tank in. Solar domestic hot water with a huge water tank is a really slick system.
Thank you.
Even in a cold climate. The problem with us in the winter in New England, if we're not near the coast, so if like you're in Boston or the coastal Maine or Connecticut, like it's actually quite sunny compared to up here, Jersey. Up here, it's really cloudy until about mid-February most of the time, although things are changing in really weird ways. And so solar, immediately you just fall off from a solar hot water perspective. But even a bit sunnier than we are, a little bit, and all of a sudden solar comes on really hardcore. And the stuff's cheap now because solar hot water industries is destroyed because propane on demand and electric on demand have wrecked that industry because and the thing about solar hot water is they're pretty expensive it's a lot of work to install them. Like it's a kind of a project. I spent $10,000 installing a solar hot water system and I did a bunch of the work myself. And so that's a 7-year payback at whatever the energy prices were then. So a lot of people don't want to do that. And solar on demand propane is like $700 for the unit and like 2 hours of installation. Like it's just a tiny project. But you're dependent on propane or electricity. So, plus if you have really hard water, it's not so great. So just for some backdrop, but yeah, solar domestic hot water. I basically got like a $30,000 solar hot water system for $1,000 if I took it if I uninstalled it off this guy's house and where I live. And because people are just getting rid of this stuff. I basically filled a shed with like solar hot water systems that I now need to install, which is a bit more daunting than uninstalling them. But, I mean, some of that stuff, like, I don't know if you're going to be able to get parts for some of this. I mean, some of that stuff stopped being made, unfortunately, maybe. Although in Germany and some countries in Europe, they're huge on solar hot water, so they may still keep it going. It really never took off in the US.
Thank you, Ben.
Yeah. Oh.
Nathan, are you hanging with us?
Wonder who the coldest climate person is here. Maybe the guy from Finland. He's still awake, I think. I think I saw him on here. Norway,
I am, and I have a
Norway,
question,
too.
and I have a question if I may.
Okay.
Although, is that okay?
Yeah. Hey.
Hi, Ben. It's your friend from Finland again. I was on your last, workshop as well. Listen, up in Nordics, in Europe, we are big on the masonry ovens, and one of the concerns that I would have, I was really impressed by that water generation ability in the wood stoves, and I hadn't really thought about. I have a system in my masonry oven. It works more or less well, but the point that you made was really good. So, but anyway, my maybe not so.
I think I lost you. Oh, did we lose the connection across the ocean?
Seem like it.
Darn. Jerry, come back.
It's a pity too, since he had the masonry oven with the water heating going.
Yeah. Oh, interesting. Huh. All right. Well, we'll have to send your question in to us, Jerry, like on an email or something, and we can maybe send it out to the group if it's as juicy as it sounds. We definitely need to see more experimentation with masonry ovens. The problem is it's just an expensive game to get into. It's like building a huge, bringing like 5,000 pounds of stone into your house is just kind of like a lot to bite off. Or 10,000. It's a great idea, but it's a little bit committing, and you needs to be on the slab. Obviously, you're not going to put that on a second floor. But if you're not familiar, Google like Russian masonry ovens, and there's people building like just gorgeous stuff, with them. Well, maybe this is a good sign off point. I don't know.
Yeah,
Jeff, you
the
still
recording's
there?
going to get sent out to everybody, so there's a
Yeah.
lot to chew on in there.
Yeah, there is. I mean, I'm kind of like, you guys should all come over. We can just discuss this in person because there's a lot to talk about. But we do that in our permaculture course. But yeah, we'll do another session for sure. I mean, there's a lot of considerations, and there's a lot to think about too in terms of solar, and it's all very nuanced with depending on your climate. Like we have learned we have to design around like no sun from November, December, January until about mid-February. And that's just very different. If like you're in Missouri, like one of the callers was, you could probably do solar year round, That's very different. That would be nice. But
Hey,
we do solar year round. It's just in the form of wood for a few months.
Hey, Ben, can you hear me?
Yeah.
Hey, I had a question earlier, but I got kicked offline when I was unmuting. But
Sure.
how far away from your heat source can you have that hot water tank, like laterally? If it was 10 feet away from the actual heat source, would that be something that's doable? Or
Well, so I think the thing is, you just need it twice as high as it is horizontally is like a guideline. I mean, I'm sure you could tweak that, but you wouldn't know if it worked or not until you hooked it up. So I think that's a good guideline. So if you want to be 10 foot laterally, you'd want to be 20 foot above, which is pretty high. You'd have to have maybe a 3-story house for that. You may be able to push that. I've just heard that's like a general guideline.
okay, cool, thanks. And another kind of quick question was, or it might be kind of a long question depending on how you go about it, but I've got a property on a main road here that we've got a organic market garden or market vegetable farm and a beef operation as well.
Yeah.
And got a property with an existing, it's going to be 2 single bedroom apartments and then also a farm store, cooling or cooler room, which is a separate building. The farm store is a separate building, and then a wash pack station, which is, they're all separate buildings. So basically 4 separate buildings.
Yeah.
Would situation where a wood boiler is a better option to try to heat all of them as one? Because we've got, between my brother's property and our property, we've got 300 acres and probably 200 plus of it is always going to be woodlot. So we've got lots of firewood.
And how many buildings to heat? Like 3 plus?
Yeah, it'd be 3 plus for sure.
And close together.
Yeah, they're all within 200 feet of each other.
Okay, so kind of close together.
Yeah, farthest.
Yeah, the closer, the more buildings you have, the closer together, the more sense a wood boiler, like district heating, they call it, makes. Like having an outdoor wood boiler, or put the wood boiler in a at least in a greenhouse, and then ship the power to the buildings with, big 1-inch, like super insulated line underground. That can be efficient, but it's not resilient. It needs electricity to run.
Right.
And there's a lot of waste heat involved.
Right.
But it's one fire. It's like 5 to 8 people can just keep one fire going. Like you could have to deal with the fire once every, once a week if you have like a good crew. But then you don't have a hearth in your house either.
Right. Yeah.
Like
well,
if it's heating homes.
Yeah. In my house, I'm looking towards an actual wood cook stove like you've got, but this will be a rental, like
Sure.
and
right. Well, then if it's a rental, you might not want a wood stove.
No, wood stove anywhere. But I'm outdoor, like you said, outdoor in a greenhouse is kind of what I was thinking. And because there's an acre plus that we can hopefully grow on down there. Well, we own an acre and a quarter, and the 3/4 of it is good tillable land that will be doing market beds in, with an option to buy more around it. So it's kind of like a farm front. But we're in New York, upstate New York, so it's cold.
Cool.
And but we've got a lot of hardwood and we've got a lot of fire making ability, and it's paying for oil right now. You know what I mean?
Yeah,
so
no, that can make sense. The thing is, though, even if you have like 1,000 acres of woods, you just remember that at some point beyond like 5, 6, 8, 10 acres, depending on how many people you have, or 10 cords, it starts to be like a ridiculous amount of work at some point.
Yeah.
Like
we're also
doing
doing
a lot of like Vermonters who burn like 10 cords in their wood boiler, and it's just, they don't care apparently, but it's a crazy amount of wood to process.
Yeah, it is. And I'm just thinking of it as like buildings heated compared to work going into the firewood, because we are clearing a lot of our land.
Cobb Hill Co-housing in Heartland, Vermont has I think they have like 30 or 40 units heated on like one tarm wood boiler, and it's really efficient.
Cool. Yeah. All right. I'll check that out.
And that's super district heating. But again, no one has a hearth in their house, I don't think. And I don't know, how do you what's the value of a hearth? It's hard.
Yeah. No, we 100% buy wood heat in our house right now, and have it any way, but
no, there's community applications for sure. I've heard there's community like Russian masonry ovens, like heating like blocks in parts of Russia and like Finland and stuff.
Oh, that's cool.
Yeah.
Nice. All right. Well, thanks a lot for everything tonight. Really appreciate it.
Thank you. Totally. Cool. Well, this is great, guys. Such a important topic. And there's still so much more to experiment with and push on it. I mean, even experimenting with wood cook stoves gets pretty expensive, because you figure, a new stove is $3 to $5, $6, $7 grand. And so you can't just, try all the models out there, but, it would be cool if between everyone we've kind of have a database of everyone trying, at least testing a lot of the options. But in this country, it's just not big. Eastern Europe has a lot of those cook stoves, and there's basically one supplier in a lot of ways in the whole country that has a lot of them. So it's a little tricky in that way. Great. What do you think, Jeff? Would think this is some good break time, or is there any?
Yeah, I think it's a good time to say to be continued.
Cool. Great. All right. Well, thank you all for being here. Yeah, huge thanks. Really great to see familiar and unfamiliar faces both, and to hear from many people from all over the world. And yeah, well, to be continued. And thanks for tuning in general. So yeah, big thanks. We'll be in touch. Stay warm. Stay woody.
Thanks, Ben.
See you guys.
Thank you.
Thank
Thank
you.
you and goodbye.
Goodbye. Here we go.